Okay, Assalamu alaikum. We have to start the third chapter of mechanics, that is about the resolving of forces. Okay. Before we do that, we need to review the concept of vectors, where you have done the magnitude and the direction of a given vector. Okay. Now let's see if, for example, there is an object over here. Okay, and you're applying a force of 10 newtons to this side, and there is a force of 4 newtons to this side. So you guys know that the magnitude of these two forces is 6 newtons towards the right side. Okay? Now what if you have a force, an object, and there is a force a bit inclined like this is your 10 newtons, and the force Newton, the 4 Newton force is acting like, for example, this is acting at an angle of 30 degrees and this is acting at an angle of, let's say, 60 degrees, this 4 Newton force. So in which direction do we have the resultant of these two forces now? This is what your third chapter is about. Okay, so now let's go back to the O-level vectors now to learn how to find the resultant in such cases. So for example, if you look at this one, this 10 0 vector, so this was this was 1 2 3 4 5 6 7 8 9 10. So this 10 0, this 10 Newton force, that was basically a vector with the column vector 10 0, and this one with the 4 Newton, that was 1 2 3 4. Okay, 4 newtons. So this is basically a vector whose column vector is -4 0. Why did we have the resultant of these two forces as 6 newtons? The reason was that if you add these two vectors, you get 10 0 and then plus -4 0, and that is going to be 6 0. And we know that the magnitude of this 6 0 is 6. If you just recall that, this is 6 square plus 0 square, so that is going to be 6 units. Okay? Now imagine you have instead of like for this case where you have the angle and the magnitude already with that. Now suppose if there is again an object over here, okay, and you have a force which is 1 2 3 4 5 6 7 8, and this is 1 2 3 4 5 6. So this is the force which has, like, this is 8 and this is 6, and its column vector is 8 6. And now there is a force over here which is let's say this is -3, this is 1 2 3, and this is 1 2 3 4. This force is -3 4. Okay, now you want to know that in which direction we have the resultant of these two forces or these two vectors. So if you add them together, that would be 8 6 plus -3 4. So that is going to be 5, and this is 10. Okay, now if you look at this 5 10, so this would mean this is like, if I use this color now, this is 1 2 3 4 5 up to here, and then I have 1 2 3 4 5 6 7 8 9 10. So the resultant of these two forces would be something like this. That would be 5 10. Now you people know that this 8 6, the vector with the column vector 8 6 has a magnitude 10. Okay, and the vector with this force with the column vector -3 4 has a magnitude which is 5. Okay, you can also find this angle over here, which is this angle is, like, if this is, you keep this as theta, so this tan theta is 6/8. Guys, you have done all of this in your O levels, by the way. Okay, so this theta is tan inverse of 6/8, and that is, I think, something around 36 point whatever like this, okay, and this one is tan inverse of 3 over, this is 4 over 3 basically, and this is going to be around 53.1 something like this. And if you want to see that this vector, which is the the resultant of these two vectors, its magnitude is going to be this was 5 10, and if you find, like, you know, this is going to be the magnitude of this is the square root of 5 square plus 10 square. So that you can use your calculator to find this would be around, like, you know, under root 125, and you can find this angle as well. Okay, now that was a little recap of the things that you have done in your O levels. Now I take you to your A level thing. Now in your A level mechanics, you will be given a situation where you have like, you know, this is an object over here, and there is a force, let's say this is 6 newtons, and there is an angle of, let's say this is 30 degrees, and there is let's say just a force like this, which is let's say this is 5 Newton to this side. Obviously you cannot just add or subtract these two figures to find the resultant of these two forces. To find the resultant of these two forces basically. So they are not written exactly in the vector form as you have seen in our previous slide, where it has shown. Yeah, it is here. Like in this, we were able to find the resultant of these two vectors because we knew these column vectors. Okay, so basically we have to learn now how to convert a vector whose magnitude and direction is there, and how to convert that back into its column vector form. So that is what we're going to learn now. Okay, so once again, please look at this. If for example, if there is a vector which is 3 4, like this is 1 2 3, and this is 1 2 3 4, so we have their components. So through these two components we can find what is the length, what is the magnitude of this vector. So that is the square root of 3 square plus 4 square, so that is going to be 5 units. Okay, and then you can find this angle, which is going to be tan theta, and that is going to be 4 over 3, and your theta is tan inverse of 4 over 3, so that would be around 53 point something degrees for this. Okay, now again, if you look at this one, now suppose you have the magnitude and you have the angle, and you want to find that what are these two components, what is this y and what is this x. So you can use your trigonometrical ratios over here to find the x and y. Like you guys know that this sine theta is y over 5, so this y is 5 sine theta. Okay, this one is 5 sine theta, and similarly your cos theta is x over 5, so this x is going to be 5 cos theta. So now, by the way, we have this theta which was 53.1 degrees, so this y is basically 5 sine 53.1, and this x is going to be 5 cos 53.1, and if you use your calculator, you will see that this y would be same as this 4, and this x would be same as this 3. Okay? Now coming to this situation where we want to find the resultant of these two forces, so we need to write them back into the column vector form so that we can find the sum of these two vectors. Okay, so if this is, for example, if this one is 6 newtons and this is your 30 degrees over here, so you must learn that this, if this is 30, this is the opposite side, so sine is like sine theta is opposite over hypotenuse. So instead of showing all these steps, you must write this directly, that this is going to be 6 sine 30 and this is going to be 6 cos 30. Now in whichever direction you have them, for example, you have a force like this, there is a force of 10 newtons, and you know that this angle is, let's say this is 40 degrees. So its two components would be, this would be tan cos 40 and this would be tan sine 40, and you can write this as a column vector like this is minus tan cos 40 and this is minus tan sine 40, because this is going towards the negative x direction, this is going into the negative y direction, so that is why we have a minus over here. Suppose you have a vector like this, and you know that this angle is, let's say this is 20 degrees and this one is, let's say this is 7 newtons. Okay, so the components, its horizontal and vertical components can be formed like this. This one would be 7 cos 20, because you know this is the adjacent side of this angle, and this is going to be 7 sine 20. Okay? Similarly, you have another force like this. This angle is 30 degrees. This force is supposedly, this is 10 newtons. So its components are going to be, this is 10 cos 30 and this one is 10 sine 30. So you must be very quick in finding the components of any force with any given angle. Like suppose this is something like this, you have this angle 40 degrees over here, okay, and this is, let's say this is 15 newtons. So guys, this one is 15 cos 40 and this one is 15 sine 40. So this is what I wanted you to recall from your O-level mathematics. I'll be coming back with you with a second video where I would directly be taking you to the situations of like where you will have to resolve the forces in your third chapter of mechanics. Thank you very much.